Okay, in this video, we're going to talk about how to use qsort function that is given by the standard library, you'll see. So let's first think about this sort program that we did before, right? Right, so sort, if you go back to sort.c, right, you usually copy and paste the selection sort and then give before function. Okay, so these are reading the data into array and then call selection sort and print it. Okay, oh yeah, it's good too, free A. Okay, anyway, so qsort function is given by the standard library. So what does that mean? I can just erase this, okay, and then change this into qsort function. Qsort function works for any type. That's pretty cool. So well, how does the magic work? Well, you give as much information as possible so that it can work out the types and stuff. And how does it work? Let me tell you. Okay, so as with catalog, you have to give the size of each element. Okay, that's one key to figure out like what's going on there. Okay, and then you have to create a function like before. Okay, and then give it. So I wouldn't call before, but I'll just say comp is a function. Okay, this is pretty interesting. This is something called pointer to a function, but so you don't really need to know the detail about it. All you need to know is what, how to create this comp function. Okay, write a comp function and then give it. Okay, so here comp function is this. Okay, remember, for the sake of it, I'll just give the type of each element, in this case double, to be t. Okay, so that we can actually understand this in more generically. But anyway, so comp function, the prototype of comp function has to be always the same. Okay, so that's how the qsort expects you to do that. And then qsort basically take that function and call it inside. Okay, well, things are kind of different in qsort because when you write the selection sort in before, well, selection sort knows the before, how it works. But here, qsort is already written, and qsort cannot know, how to compare it. That's why comp, the function, has to be given as an input to qsort as the last argument. Anyway, so the prototype of the comp function is looking like this. Const void, let's say xp, and const void yp. Okay, so what is xp and yp? Xp is address of an element, okay, and yp is address of another element. This is similar to the double AB in before function, but well, the qsort does not know. That's why you have to pass the information of the two elements with a type neutral technique. So void star is really, well, it can be anything. In C, if you don't want specific type of an object, then you use void star. It's an address of something. Okay, you deal with it inside. And const is, well, you cannot change it. So this const keyword, we don't usually use it, but somehow the comp function must, take this form. So that's why we have to use const. Const is really what is constant. Don't change xp and yp or inside it. Okay. Okay, that's the input. And then output is not the Boolean, but this is what? Something similar to the string comp, how string comp works. What does that mean? So if xp, whatever it is, the contents of xp, okay, X element, I will say X element if X element is what? Greater than Y element, okay? And then what? This is greater than 0. The output should be greater than 0. X element, yeah. If the same, then return 0, okay? And then what? Return this. That's basically as before. Remember? Okay, so now let's define this comp function. How do you define this comp function? Well, you get the address, right? So that means what? You gotta change the, you gotta give the specific type. So let's say, well, the address of element should be actually double star, right? Because we're dealing with double element, and the address of each element is double star. Let's say AP is what? The pointer to the actual array. So I'm just cast that, I'll say T. T is double, okay? T is the actual elements. T star is the address of actual pointer, okay? And XP is void pointer. I don't know the type. You deal with it. That's what comp function is telling you, but, okay? And then what? Okay, I know the actual type. This is T star, okay? So same wise, okay, YP is this. So now you have actual address, okay? So T is what? The actual element. So you do dereferencing, go follow the address of what the AP has, and then this thing is B. So now you finally got A and B. And then what? Well, return the appropriate value. So the way to return is this. So then what? A minus B will be negative or 0 or positive, depending on how those things are compared, like string comp, but we're dealing with double. Okay? Does it make sense? Okay. So let's compile this. Okay. Works. Let's do that. Well, it's 5. Okay. 5. 7, 4, 1, 3, 9. Okay. It's sorting well. Okay. Of course, if you change the comp function to be what? B minus A, what will happen? 7, 4, 1. Because you change the sign, you actually sort things in reverse. Okay, so you can sort the other things. For example, if you think about sort 2, so remember this is what? Allocating to the array of char, so right? So that means what? We're sorting the strings, right? So as before, remember, now the type is what? Char star, because you're sorting strings, okay? But here it's the same, qsort A and size of T, whatever T is, in this case, char star, and then you give comp function, right? And then comp function is basically the same prototype. Okay. And then what? Let's just copy and paste the comp function. Okay. So up to here, it's the same. You got A and B element. And remember, type T is what? Type T was what? Char star. It's a string. Okay. So how do you compare? Well, what is the natural way to compare like 0 and 1 stop? Well, sorry. Okay. How do you compare 0 and 1? Or, sorry, plus, minus, and 0? That's actually, what string comp works naturally. So we just call string comp and return it. Okay. And then whatever string comp, outputs will be the output of this comp function. And that's it. Okay. So now what? You compile it, sort to, okay, enter n, sort by 4, hi, world, IC210, cool. So then you can actually sort it beautifully, okay? If you want to sort case insensitive manner, then what? What we did was what? Create a capitalized function, right? So void cap char star a, and this is s, right? And then basically scan each element, right? If s of I is lowercase letters, and then what? I want to change this to be capitalized. How do you capitalize? Find the what? Offset, or how far away from this A, and then just add back. So that will give you how far away to be, how far away it is to be from, how far away it is from the capital letter A. Okay, and that's it. So here, what do you do? So basically what? You created temporary A, right? Temporary A, and then TA is now copied, and then you capitalize TA. So now we have capital TA, and then you create another temporary string stack based, and then capitalize TB, and then what? Now create what? TATB contains the capitalized string, and then you just compare based on the capitalized one. Okay, so if you do that, okay, let's put some hi world IC210, IC210. Okay, so then it's still search is done, what is comparison is done by the case insensitive manner. Remember, if you just ditch all this stuff, but change back A and B and compile, and then if you do the similar thing, it's case sensitive based on the what ASCII code, and then capitalized letter first and then lowercase letter last.